Hi guys, in this video we're going to talk about Python data structures. The first thing you're going to want to do is pop into Schoology and you're going to see a notebook assignment named data structures. If you can go find that Schoology assignment, you're going to download this Python notebook and you're going to drop it into your Python folder. You can see I've already dropped my data structures notebook in right here. I'm going to work out of my period 4 folder. You guys probably are just going to work out of your base Python folder. All right, once you have the data structures notebook loaded in, you're going to go ahead and open up Jupyter. So you'll get the kernel opening up like this. And then once that's done, you'll have a copy of Jupyter. I'm going to go to period 4. I'm going to go to my data structures notebook. And this is what we're going to be working through. Now, data structures. Data structures are basically different ways of storing a data set. And the idea here is we could pick a different way of storing and representing our data depending on how we're planning on using it. So let's add some bullet points here. I'm going to say we can pick a different data structure depending on, and there's really a couple factors. One factor would be how we plan on using the data. Another factor would be how we plan on accessing the data, and the size of the data set. Now, the idea with this is some data structures might be fast for certain types of lookups, and they might be slow for other types of lookups. They might be fast for certain types of transformations, or slow for certain types of transformations, and so it's all about optimizing for how we plan on using our data set. And we'll see that throughout this notebook. We'll create a couple different kinds of data structures and kind of see the pros and cons of each of them. As you work in the field of data science, thinking about what the appropriate data structure for your data set is something that you're going to want to think about. Now, we're going to start pretty straightforward. We're going to look at 3 different data structures. We're going to look at lists, we're going to look at tuples, and we're going to look at dictionaries. This is a little bit different than when we were working in JavaScript, where we basically just had arrays. Python gives you more flexibility, more data structures depending on your needs as a programmer and as a data scientist. All right, let's do something very similar to arrays from JavaScript. Now, you guys will notice that I'm going to get to work through this notebook a lot faster than I normally would during a normal class period. And the reason is, you guys noticed this during class, I have to kind of stop and walk around and help people out, take questions, slow down if someone was still typing. The one benefit of working remotely like this is you guys can pause the video where you need to, you can rewind the video where you need to, you could stop and ask the person next to you or ask the intern in the class for help and pause the video while you're doing that. And for those of you who are breezing through the notebook, you could just keep breezing through it at your own pace. So this video should go a little bit faster than an in-class lesson would, but don't be afraid to press the pause button. Don't be afraid to rewind. All right, so we're starting with something very straightforward. In Python, this is called a list. It's a list containing 3 string elements. We've got pink, yellow, and green, each string representing a color. Now I'm printing the colors here. I get pink, yellow, and green. This looks very similar to JavaScript. And in fact, a list in Python works pretty much the same way a list in an array in JavaScript would work. Now, you might want to append another element to this list. So I could write colors.append, and maybe I want to add blue to the mix. And I could print out my new colors list, and now I have pink, yellow, green, and blue. All right, so we're appending. Append means add it to the end of the list. Maybe you have a couple colors that you want to add to the list at once. Well, we could do that. We're going to use the extend method. So this is a list method that allows us really, it says extend. I almost think of it as merging because I have to create a second list. Let's say this one has purple and aqua in it. And the extend method will take my colors, pink, yellow, green, and blue, and merge it with purple and aqua. And we can print it out. There it is. Pink, yellow, green, blue, purple, aqua. If you ever need to know the length of your list, which is pretty helpful when you are analyzing the list, computing averages, just trying to loop over the list, knowing the length of the list is pretty helpful. The length of the list in this case is 6. All right, and let's write just a little algorithm here that's going to loop over this color list. All right, so feel free to pause this at any point if you need more time to type, but I'm going to write sock list equals an empty list. I'm going to import random, and I'm going to say for I in range length of colors, actually len of colors, I'm going to say sock color equals colors at I. I'm going to say sock quantity equals random.rand int between 0 and 10. And then notice I'm going to use the str method to change an int into a string. Python is pickier about data type. So in JavaScript, it was okay to kind of add a string and an integer together. JavaScript would just concatenate those, assuming that you meant for everything to be strings. In contrast, Python's picky. So we're going to write this, we're going to concatenate a string here. I'm going to write I have, not I hate, I have plus str sock quantity. So I'm parsing sock quantity as a string plus pairs of plus sock color. Oop, and that's a variable, so not a string there. Plus socks. Okay, so I'm concatenating a little message. I have 11 pairs of blue socks, or whatever it's going to say. And then I'm going to write sock list dot append sock message. And at the end, I'm going to print sock list. And I have 10 pairs of pink socks. I have 4 pairs of yellow socks. I have 2 pairs of green socks. I have 9 pairs of blue socks, 3 pairs of purple socks, 7 pairs of aqua socks. So what's happening here? I'm looping over all the colors. And for each color, I'm concatenating a little sentence that says I have some random number pairs of that color sock. I have 10 pairs of pink socks, 4 pairs of yellow socks, so on and so forth. So I'm creating a list with all of those strings in it. And yeah, pretty straightforward. Now, there will be other ways to loop over lists as you get more proficient with Python. So for now, thinking about indices is probably a good way of doing it. But as you get more advanced, you'll find other ways to loop over lists that are maybe more readable than what we're used to from JavaScript and now Python. What you'll often find is there are certain things that you could do something in Python the same way you did it in JavaScript for the most part, or you'll find out there are more efficient ways to do the same thing in Python, but you get to write it, in a more simple, abstracted fashion. All right, let's talk about how to search. Okay, so the syntax is we ask if a certain item or element is in our list, and we could search for that item in the list. So, okay, let's take a look. So I'm going to create a variable called yellow, and I'm going to say yellow, the string yellow, in colors. What will this do? Well, this is going to go through my colors list and check if the string yellow is in my colors list. And if it is, this is going to evaluate to true. So yellow will return true, or will have the value of true, otherwise false. Let's try another one. Orange. Orange is going to equal orange in colors. And I could try printing these. I could print yellow, and I could print orange. And as you might expect, one of these evaluates to true, the other one to false, just so we can see both cases, and makes sense that yellow would evaluate to true, because if you look at your list, yellow is in that list. But if you look for orange, it's not there. All right, so that's how we search, or that's one way of searching in a list. We just simply ask, you could think of this almost like a question. Is yellow in colors? That's either true or false. So the answer to that question will be true if it's there, false if it's not. All right, let's get to something that's really cool. Python is the first language I learned that does slicing in this way, and it's just very clever how it works. You could do a lot of string manipulation and a lot of list manipulation using slicing. So first of all, let's remember what's in colors. It's pink, yellow, green, blue, purple, aqua. And each of these elements has an index. In fact, what I'm going to do here is I'm going to insert a cell below. So normally I would do this at the whiteboard. I'm going to change this to Markdown. I'm going to put in pink, yellow, green, blue, purple, aqua. And I'm going to remind you that pink is indexed at 0, yellow at 1, green at 2, blue at 3, purple at 4, aqua at 5. I'm reminding you of what the indices are. Let's put a return in there. There. Put some more spaces in. It's unfortunate. I thought the spacing would kind of hold. Okay, it does not want to keep that spacing. That's all right, though. You know what I'll do is I just won't shift enter this. It's interesting that Markdown in a Jupyter notebook does not pay attention to space bars. But anyway, okay, so I've got 0, 1, 2, 3, 4, 5. Now, here's something kind of crazy looking. I am going to print the element in colors that is indexed at -2. And you might say, wait a minute, my items are indexed at 0, 1, 2, 3, 4, 5. I don't have an element indexed at -2. Well, Python is going to allow you to count backwards. So if you start at 0, and then you kind of think about yourself going to the left rather than to the right, to the left of pink, think of that being aqua. That's indexed at -1. Purple at -2. Blue at -3. Green at -4. So on and so forth. Yellow at -5. So if I print colors at -2, I think that's going to give me purple. Let's try it out. Shift enter. Yes, indeed, it's purple. Now, what is that useful for? The most common way to use this is to look at the color or the element in a list indexed at -1. You often want to know what is the element in my list, what is the last element in my list. And your list name at -1 is going to be the fastest way to grab that element. So anyway, colors at -2 is the color purple. Okay, we could use slicing to get a range of elements. So I'm going to print colors, square bracket, colon, 2. Now what this tells us to do is get all of the elements starting from the beginning of the list up to but not including the element indexed at 2. So if I run this, I think it's going to give me pink and yellow. And the reason I think it's going to give me pink and yellow is this says, give me all elements starting from the beginning up to but not including the element indexed at 2. Now the element indexed at 2 is green. So I think I'm going to get pink and yellow, but I'm going to stop before I print out green. And there it is, pink and yellow. So this notation says to print the elements from index 0 inclusive to index 2 exclusive. Exclusive meaning we're not including green in this. Okay, next we have print the elements from index 3 inclusive to the end of the list. I'm going to write print colors. I'm going to start at 3 and I'm going to go all the way to the end of the list. Now in a similar fashion to the previous one, notice how I'm not writing anything after the colon. If you don't write anything before the colon, that means start from the beginning. If you don't write anything after the colon, that means go all the way to the end. So I think I'm going to get blue, purple, aqua. And there it is, blue, purple, aqua. Starting at 3, which is blue, then purple, and then all the way to the end of the list, inclusive, which is aqua. Next, I've got print the elements from index 1, inclusive, to index 4, exclusive. Oh, I think that's pretty straightforward. Print colors, starting at 1 inclusive through 4 exclusive. When you specify the number at the end, when you specify that, that means that it is exclusive. So I get yellow, green, and blue, and you can see that makes sense. I need the elements indexed at 1, 2, and 3, but not including 4. Well, at 1 is yellow, at 2 is green, at 3 is blue, and then I'm not including purple because that's the exclusive element indexed at 4. Print the list backwards. This is interesting. Watch this one. Print colors, colon, colon, -1. Now, before the colon means start at the beginning. Between the colons means go to the end. So I'm going to start at the beginning of my color list. I'm going to go to the end of my color list. And then this -1 tells you what to jump by. So my jump here is -1. Basically, it tells you to go backwards. So start at the beginning of your list and start listing out elements backwards. So aqua, purple, blue, green, yellow, pink. I'm working backwards through my list. I've reversed my list by simply putting colon, colon, -1 there. Pretty cool. Now, as you work through Python, one thing you're going to notice is there's so many data structures, so many different ways of representing your data and transforming your data as you work through things. You're going to want to remember this method called type. Type tells me that the data type for this structure is a list. Right now, the only data structure you know are lists, so we kind of knew that the data type of colors was going to be a list. But as you really start working through Python, you're going to know all these different data structures, all these different ways of handling large data sets. And so using type will help you keep track of, like, wait, which data structure am I using right here? Especially because you're going to find out there's methods that will transform your data. It might start as a list. You do some method call, and suddenly your list is a dictionary. And then you're like, oh, shoot, wait, what is my data type now? This little method of type will help you keep track of that. All right, so slicing. I alluded to this earlier, but slicing also works on strings. So you could kind of think of a string as an array of characters in a sense, right? As a list of characters. So slicing will work on strings in the same way it works on a list. So I'm going to slice out dark and stormy night. Let's see. So I is indexed at 0. You know what? I'm going to do something right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the letter D in dark is indexed at 9 because the I is at 0, the T at 1, so on and so forth. So if I want to slice out dark and stormy night, I'm going to print my sentence. I'm going to start at 9 inclusive, and then I'm going to put a colon there, and I get dark and stormy night. Done. All right. Now I guess technically it says slice out dark and stormy night, but it doesn't include that period there. Can I make that work? Yeah, if I put a -1 there, I could be even more correct. So you could choose which one you like better. Let's put both of them. It's both good code to look at. So the first one, I said print my sentence, starting at the character indexed at 9 and going all the way through and including the end. In the end, there's a period there. So it's going to include the period. Now, if I want to be very precise based on the specifications here, it actually says slice out dark and stormy night, not including the period. Well, if I slice starting at 9, inclusive of that letter D, and then put a colon to -1, that says go to the negative first character exclusive. So it's saying go to this period, but don't include the period, meaning we're to stop at this letter T in night. Pretty cool. Lots of flexibility in Python. All right, let's keep rolling here. Okay, this code's pre-written for you. I don't think you have to add anything to it. Let's see. So this is an acrostic. You might be familiar with acrostics from like grade school. You like write them on Mother's Day. You write a poem to your mom, and like you know, the first line of the poem starts with M. The next line of the poem O. You know, M-O-T-H-E-R. Whatever, you spell something out. So this is an acrostic by Edgar Allan Poe. You can see the first word in the poem is Elizabeth, and then you look at the start of each line, E-L-I-Z-A. It spells out Elizabeth again. So I wrote some code here to extract out this acrostic. So secret message, I'm setting it to an empty string. Now I'm saying that for my acrostic, I want to split on line breaks. So I'm splitting this on the line break character. And then I'm writing for line in acrostic. For each line in my acrostic, my secret message, I'm going to concatenate the 0th character in that line. Well, the 0th character for each of these will be, E-L-I-Z. It'll be the first character, right? The 0th character is the starting character of each line. Run this code, and there we go. Elizabeth. And, if you had a more complicated acrostic, something that's over hundreds of pages, you wouldn't want to do that by hand, but you could have Python do it for you, and it would run in less than a second. So pretty cool. We extracted a secret message out of an Edgar Allan Poe poem. All right, let's keep going here. So we have a new data structure. They're called tuples. And a tuple, you can kind of think of it like an ordered pair from math class. They can get longer than just an ordered pair. You could have multiple elements in them. But typically, tuples, you're going to use them the same way you use lists, but you're going to use them when you don't want the data to be modified. So there's no appending on a tuple. There's no changing a value in a tuple. So it's kind of like a tuple, but much more, or it's kind of like a list, but much more static. And there are certain times when you're writing a computer program that you want to make sure that your data gets preserved. Remember I said the different data structures, you pick them based on how you're going to use your data and how you're going to modify or change your data. A tuple would be you saying, this data is immutable. It cannot be changed. I don't want to change it. Like maybe think about like the digits of pi, 3.14159.265. Those are, you could store each of those digits in a tuple in the sense that the digits of pi should never change. You shouldn't accidentally write a computer program that changes 3.14159 to 7.14159. That's probably a bug in your code if you changed pi to 7.14159. So tuples are a way of recognizing the immutability of a piece of data. All right, so I could write a tuple like this. I could say A comma B equals 50 comma 90. Look at this, print A, print B. Oh, okay, A is 50, B is 90. Now, you could use parentheses if you want. Doesn't matter. Tuples are kind of interesting. You can optionally use parentheses, or you could leave them off and be kind of lazy about it. The code's going to work no matter what. There's pros and cons to this. There's certain situations where I put the parentheses in. There's certain situations where I leave them off. It really depends on what I'm doing. For something short like this, this code's easy to read. A comma B equals 50 comma 90. This is saying A goes to 50, B should be stored as 90. So the value of A is 50, the value of B is 90. That gives us a pretty cool technique that you actually can't do in JavaScript, variable swap. In a lot of other programming languages, you would need a temp variable, a temporary variable to swap the values of two variables. You guys have seen this before. You'd say something like x equals red, y equals balloon. Your goal is to swap the values of x and y. So you want y to become balloon and x to become red. You would do something like, I don't know, temp equals balloon. And then y is equal to red. And then x is equal to temp. I'm using a temporary variable to hold on to an extra piece of data. And then, whatever you run, when you run this, you don't actually have to type this one, but I'm going to erase this in a second. I'll show you how we do this in Python. But good, I did it. I swapped the values of x and y using an extra third temporary variable that I called temp. If you don't have the temporary variable, you're kind of in trouble with this traditional technique. If you do something like, oh, no, Gratoni, you don't need temp. You just say like y equals x, and then oh, darn, they both end up as red, and you have accidentally lost data doing it like that. So in JavaScript, you would have to write code kind of like this with a temporary variable. In Python, watch what I'm going to do instead. I'm just going to say xy equals red, comma, balloon. Let's make sure I just didn't mess anything up here. I'm going to print x and y again. Print x, print y. Okay, yeah, x is red, y is balloon. My goal now is to write some code to swap that. I want x to be balloon and y to be red. I'm going to do that in the next line of code here. So I'm going to write xy equals y comma x, and I'll print x and print y again. And look at this. In a single one-liner, x comma y equals y comma x. X is now balloon, y is now red. And the reason that this works is it's all in a single line. So all at the same time, x gets assigned to the value y, at the same time y gets assigned to the current value of x. So we get this swap happening before we've accidentally lost any data. And right here, I showed you guys how to do it in a different language with a variable swap using a temp variable. All right, let's keep rolling here. By the way, guys, at some point this is a 2-day notebook. So at some point the bell's going to ring and you're not going to make it through this whole notebook. It's okay to finish it, on the second day. Okay, I'm going to define a function called sum product here, x comma y. And this function, I'm going to take s for sum equals x plus y. I'm going to take p for product, x times y. And I'm going to return s comma p. I'm returning a tuple. I'm returning two values. So I'm going to say sp equals the sum product of 4 and 7. Sorry, I need an equal sign here. sp equals the sum product of 4 and 7. And I'm going to print the value of sp. And theoretically, this function should return the sum of 4 and 7, which is 11, and the product of 4 and 7, 28. And look, it gives the tuple 11, 28. So my function can kind of do double work. It's giving me an output of 11 and an output of 28 as a tuple here. Kind of two outputs. Kind of nice. And remember, I'm going to remind you of this early and often in this course. You always want to check your data type when you're working, whether you're working with a list or a tuple, or you could see we're going to be doing dictionaries soon. These data types can be transformed. They can be changed by methods. So you always want to double check, what is my data type? In this case, as you know, we're working with tuples. Now, you noticed that the sum product spat out two values, 11 and 28. We can actually assign those two return values to different variables with a single one-liner. I'm going to write a comma b equals sum product of 4 comma 7. And look at this. I've gotten the value of a assigned to 11, and the value of b will be assigned 28. So the first value that some product spits out is going to be stored in the variable A. The second value that some product spits out is going to be stored in B. And there we go. A is 11, B is 28. All right, we're pretty much wrapping up with tuples here, but notice if I check the data type on A and the data type on B, these are no longer data structures, these are integers. So you could think of this tuple as a tuple of integers. This first element is an int. This second element is an int. And so this tuple is a tuple of two integers. So A and B are actually integers. All right, finally, we're going to talk about dictionaries. I would say this is my favorite data structure in Python. What's beautiful about dictionaries is that they are designed for fast lookups. So we're really starting to get to the data science type of material in Python. Data science in the sense that if I have a dictionary with, I don't know, 1 billion values, and I want to say, hey, is this particular value in my dictionary? With an array, with a list, Python would have to look at each element individually. Is this first element the one you're looking for? No. Is this second element the one you're looking for? No. Third element? No. And it's going to keep on going for, perhaps billions of elements. Very, very slow. Dictionaries use a different type of mathematics. It uses a hash table to look it up very, very quickly. And so we're not going to learn exactly the details of how a dictionary does what it does, but we are going to leave this course knowing that dictionaries are optimized for very, very fast lookups. I can look and see if a piece of data is in my dictionary and find where it is very, very fast. Okay, let's do some ID numbers. So, you know that at Fremd High School, every student has an ID number. So I'm going to make up a fake school here with an ID number of 8717. That student's name is going to be J. Cole. And then let's do another ID number, 2309. That student's name is going to be Kendrick Lamar. You might be noticing a trend here. An ID number of 4008. That's going to be a student named Drake. 9904. That's going to be a student named Cardi B. And then how about an ID number of 1576? Again, J. Cole. And then let's print it, make sure we did it right. Print ID names. And actually, you know what? I meant to do this in lower camel, not in lower camel case. I'm going to use underscores. Python prefers underscores when we're naming variables. So I'm going to name it ID names with underscores there in lowercase. Anyway, let's take a look. All right, so what's going on? This is similar to Fremd High School. Each student has a unique ID number. There are no two students currently at Fremd High School that share the same ID number. That's a unique identifier for the students at Fremd. However, names are not actually unique. It's possible for there to be a John Smith that maybe is a freshman at Fremd and another John Smith that maybe is a junior at Fremd. Names, values in this case, values do not have to be unique, but keys do. So these ID numbers, we call them keys in a dictionary. And then we have values as well. So the keys are these 4-number ID numbers. And then the values are these names. Keys are unique, values are not. All right, or values are not necessarily. Also, the keys are unchangeable. You can't change them. So once you have set this dictionary, the only way to change a key would be to make a new dictionary. So immutable means unchangeable. All right. Why don't we look at the data type here for ID names, by the way? So I'm going to write type ID names. Yeah, the ID names data type is a dictionary. Okay. Now, like I mentioned, lookups are very, very fast in a dictionary. That's why we would use it. So I'm going to print ID names, and I'm going to look up the student with an ID number of 8717. J. Cole. Now, you're not going to notice how fast this is for a short dictionary like this, but if this dictionary had terabytes of data, it would still run very fast. And if you were trying to look something up in a list, it might take hours to run, while in a dictionary it would happen in a split second. Let's try some other stuff. ID names. Let me make up an ID number that's not in there. Let's do 8718. Oh, I get a key error. The key error is telling me, like, hey, this ID number, this key is not in our dictionary. So if you try to look something up and it's not there, it does produce an error. Let's change it to something that works, 2309. There we go. Kendrick Lamar. All right. While the keys in a dictionary are immutable, the dictionary itself is not immutable. What I mean by that is we can add more values to a dictionary. Just like new students can enroll at Fremd High School, similarly, we can add more key value pairs to our dictionary. So let's do that. Let's go to this next cell that says assign new value pairs. I'm going to zoom in here just so everything's a little bit easier to see. And we're going to enroll 2 new students at this school. ID names 1822, that's going to be our key. And we're going to assign that to a value of Post Malone. So that's a new student with an ID number of 1822 and a name of Post Malone. And then ID names 3310, we're going to say that equals logic. And let's print out ID names. And there we go. We can see that we have key value pairs. The key is like the student's ID number, the value is like the student's name, and here towards the end, here's an ID number of 1822 with a value of Post Malone, and an ID number of 3310 with a value of logic. So a key and a value, a key and a value. So dictionaries, you can add values, key value pairs as you see fit. Now we could look at the length of this dictionary. So I can write length equals the len of ID names and run that. And, oh, I forgot to print it. There we go. Our dictionary has a length of 7. Now at Fremd High School, you'd have a much larger dictionary, right? You'd have 2,800-ish students. So this length would be not 7, but somewhere on the order of 2,800. And if you're doing data science, the size of your dictionary might be millions or billions of key value pairs. And what's really cool about a dictionary is we have the ability to do very fast lookups. So if we want to see if 2309 is in ID names, if there's a student with an ID number of 2309, when we run it, we get true. That ran very quickly. Of course, for a list or a dictionary, that's going to run very quickly when your list or your dictionary only has a length of 7. But this would run very quickly even if we had millions of names in our dictionary. Even if we had millions of key value pairs in our dictionary, that would run very efficiently. Now let's try an ID that is not in our dictionary. So I'll try 2310, and I get false. All right, so that pretty much wraps us up on our main data structures. There are more data structures in Python, but those are the main ones that we want to look at today. And let's move on to our tasks. So your first task is to use a for loop to create a list of 31 random numbers between -5 and 35. So you'll write the for loop yourself, but you want to output a list of 31 random numbers that go between -5 and 35. If you rerun the code, this should change. So you wouldn't expect to have -4, 31, 0 in your list. It would be some other random numbers between -5 and 35. That's task 1. Now in task 2, we're going to start to interpret this list as essentially a list of winter temperatures in Chicago. Right? If it's January, February, something like that, the temperature is going to range somewhere between 5 below 0 and 35 degrees on average. So let's pretend that this is a list of 31 temperatures in January. Now, you're going to check if 32 degrees appears in your list of temperatures. It might not. This is a random list, so um, it's a pretty good probability of it being in there. There's also a chance that it's not. Then you're going to pick a temperature that you know for sure appears in your list. For example, in my list, I know for sure -4 is in that list. I'm going to write some code that shows that -4 degrees definitely appears in my list of temperatures, or some other choice that you might pick. And then you're also going to verify that the length of your list is 31. So you have 3 little mini tasks, just kind of practicing with checking if elements are in a list, finding the length of the list, so on and so forth. And finally, in task 3, you're going to use print and your previously defined list to write a for loop that does this. Basically, print out a bunch of descriptive sentences about the temperature on various days in January. So if we pretend that this is a calendar of January temperatures, then this might be January 1st, -4 degrees. The temperature on January 1st was -4 degrees Fahrenheit. And then 31 here, the temperature on January 2nd was 31 degrees Fahrenheit, so on and so forth. Your numbers are obviously going to be different for these temperatures because these were randomly generated. All right, so those are required tasks. Those are your homework. And then if you do want a little bit of extra credit, or you just want to work on something interesting, there is this challenge. Now, don't let this get in the way of in-class work. This would be something that you would do as homework, but there is an extra little task here that you could try out if you are interested in writing a little number-based converter, just like we did first semester with JavaScript.